Okay. Now you're talking about testing of means. There's a lot of tests here, right? So what are the tests we done? We had one sample t-test, independent sample t-test, paired sample t-test, and ANOVA. So all comes under testing of means. It's where p-value are used for every test. All right. First test. This is one sample. You want to test. What's the test you used? What's the name of the test?
One sample t-test.
One sample t-test. This box represents what? What does it? Yeah. This box represents. What's the box represent?
Population.
Population. How many boxes here?
One.
One. So we one population. The circle represents?
Sample.
Sample. How many circle?
One.
One sample. That's why it's called one sample t-test. Right? Objective to test if the mean in the population is mu naught. So mu naught is a tested value. Or can write hypothesis, objective or hypothesis. H now the mu is mean, symbol mu is mean. Mean equals mu naught versus mean is not equals to mu naught. Example, mean BMI is 25 versus mean BMI is not 25. So how do you determine the p-value? Look at this formula here. So in this class, you don't need a formula, but he didn't know what to test and which function to use. So look at this formula. What's the numerator in the formula? What's the numerator in the formula?
Mean.
This is sample mean. This is tested mean. Okay? Sample mean and tested mean. So now, that's a formula. Just talk the numerator only, up there only. Here, tested mean, sample mean are same place, equal. Therefore, T must be? T must be?
0.
0. This minus that 0. So P will be 0.5, half the curve. In this case, tested value and sample mean, are they slightly different? Here, these two are equal. What about here? Is sample mean slightly bigger than tested value? Huh?
Yes.
What about here?
Very big difference.
Very far, very big difference. So these two are equal, the T will be 0. And these two are not far from each other, not very far, T will be small. And in this case, T will be very big. Right. Small t means what? Now small t means what? Go backward. Small t means what? T0 means what?
P equals to 0.5.
No, the t equals 0 means what? Go backward. Means what?
No difference.
No difference. Tested value same as the mean, sample mean. Tested value same from the mean came from the sample. This means what?
Small difference.
Small difference. That means not much of difference. This means what? T big means what? T big means what?
Big difference.
Huh? There's a big difference, tested value and the sample mean. Question is, how do you know T big or small? You observe the p-value. The p-value of the test less than 0.05, then you say T is big, then you say the mean is no more the tested value. If the P is more than 0.05, we say T is small, therefore not much a difference between sample mean and the tested value. So in this case, H null won't be rejected. In this case, H null will be rejected. So what's H null? The sample mean equals to this tested mean, right? That means these two values are very close. How do you know very close? We look at the p-value, more than 0.05, t is small, meaning these two values are very close. So in this case, we do not reject each null. But that's the case now. T is big, mean, sample mean, and tested value are very far apart. Therefore, reject each null. That means this is not true. Reject each null. In this case, they are very close. Do not reject. In this case, they're exactly the same. Do not reject. Right? So that's how you're going to look at it. Right. This example. What do you want to know? What do you want to know? What do you want to know is objective. What do you want to know?
To
What's the heading?
test the population mean equal to 25 or not.
So we put there 25, whether it equals 25. Then what do you do? You take a sample, size n, measure the mean, x bar is the mean, S is standard deviation. You can write objective or you can write hypothesis. So that's the formula that holds. We're going to do some analysis. We observe the p-values and make the difference. Whether difference or no difference, make a statement. Assumption. Cases are independent of each other and data at least fairly normal. Later we go to assignment. When I give an assignment, if I say one sample t-test, you must know what is assignment. The cases, it means your sample, in the sample case 1, 2, 3, 4, they must be independent of each other. And they must be fairly normal. Do you know how to test normality?
Yes.
Yes. That's why we did normality, right? That's why we did mean. That's why I did standard deviation and a lot of other things. All these are useful for this kind of testing. All right. Can you open the file again? Data set 1. Procedure to test with the mean is 25. Right? I wanted the mean in 25. Open the file and follow the instructions. Analyze, compare mean. From here onwards, I'm not going to show you how to do it. You follow the instructions in the yellow box. Right? So do this. This will pop out. Bring BMI into the test variable. Test value 25. That's all. So whatever discussed just now, click button, the answers will be in the outcome, output.
Okay.
Are you all done?
Yes.
All right. Okay, let's see the output. There are two tables. First table is descriptive statistic. This is describing it. Body mass index, the sample size 108. The mean is 28.4, we did last week. Standard deviation is 5.2. So first you write, sample mean is 28.4 plus minus 5.2. You must tell the reader. Next, in the test, what test? I say in the test, what test?
One.
One sample t-test. What are you testing? What's the test value?
25.
25. Test value is 25. Sample means 28.4. Right? So it calculates the t value. Is it a big T or small t? T start from 0 and increasing.
Big.
Is t big or small? Look at the p value. Is this p value less than 0.05?
Yes.
Less than 0.05. Therefore, these two are very much different. So we say the mean is not 25. I want to know whether the mean is 25. The p-value of the test is less than 0.05. Therefore, the mean is not 25. What's the next question? The mean is not 25. What's the next question? The mean is not 25. What's the next question?
It has a significance.
Then where is it? If the mean is not 25, then where is it? What do you do? To the last two columns, we add the tested value to the lower, that is 27.4, and add to the upper, that's 29.4. See the flow? We took a sample size of 108. The sample mean 28.4 plus minus 5.24. In this test, one sample t-test, the p-value is less than 0.05. Therefore, the mean is not 25. The 95% CI confidence interval, just add these two. Add these two and report. That's where it is. You're asking whether 25. No, it's not. Then where is it? Somewhere between 27.4, somewhere between 27.4 and 29.4. The real conclusion, we are 95% confident mean BMI in the population is between these two values. So that's my objective. This is my analysis. This is my results. And that's my conclusion. The conclusion says the mean is not 25. We are confident 95% is between 27.4 and 29.4. All right. Without further analysis, let me ask another question here. Is it possible the mean is 26? Is it possible the mean is 26?
No.
Take the 26. 26. Does 26 fall inside or outside?
Outside.
Outside.
Yeah. Therefore, it's not 26. It's more than 26. Is it possible mean is 28?
Yes.
Where does
Yes.
it fall? It falls inside here. Yes, possible. Is it possible mean is 32?
No.
Where's 32 fall? Outside. Right? The answer question, is it possible means 26? 26 falls outside. No, it's not. It's more than that. Is it possible means 28? 28 falls here. Yes, it is possible. Is it possible mean equals 32? 32 for outside here? No, it's not. It's less than 32. So many inferences can be made on this, not the p-value. So nowadays, journals, they want you report the confidence interval. Don't report p-value is fine, plus the confidence interval. Are we clear?
Can I ask you a question?
One?
What is the function of the one sample t-test? Is it only to find out the mean, or
In the population.
only find out the mean? There is no other
No.
function?
No, look at here. Test if the population means something. Testing one sample, this one population, this one sample. What are you testing? Testing the mean. Mu is mean. So this is one sample test for mean. So look at the formula. This is the sample value. This is the tested value. So when you're talking about what you observe in the sample, is it far from the tested value? So here we're doing BMI, is it 25? And then our descriptive, it is 28.4, this X bar, this mu naught. This and this, are they far apart? So look at the t-value. T-value far from 0. Therefore, P is small. P small means there is a difference. Mean it's not 25. In this case, we reject H null and accept the alternative. And then construct the confidence interval. So this is for only testing a population mean, only one mean, one population. Am I okay? Dama,
Yes.
is it okay?
Yeah. Okay.
All right. So decided it. Now do this example. Do the same thing. Now test the mean SBP, systolic blood pressure is 130. Test whether systolic blood pressure is 130. Are you done?
Yes.
Okay. So look at the table now. So this is a descriptive statistics. What do you pick up from here? The mean plus or minus standard deviation. So you're right. Mean plus or minus standard deviation. So we are testing whether mean is 130. We observe 128. How much difference? How much difference between these two? So that's a mean difference. A difference of 1.3. So calculate the t-value. This t-value, is it big or small? Is it close to 0 or far from 0? That's where
Close
the
to
p-value,
0.
p-value comes in. Is the p-value more than 0.05?
Small. More.
Yes.
P-value, is it more than 0.05?
Yes.
So
Yes.
do not reject H null. What's H null for this? How do you write H null? Do you write H null? How do you write H null? What's H null here? Just now, I showed H null, right? This H null, mean equals to mu naught versus mean is not equal to mu naught. Okay. Here, what's H null? What's H null?
Systolic blood pressure.
Not here, BMI. What's H null? You write H null, what will it be? What are you testing? H null mean equals to 25. H alternative?
BMI not equal to
Not
25.
right, not equals to. H null mean equals 25. Alternative mean is not 25. So p-value less than 0.05. Reject H null. That means mean is not. Reject H null, accept the alternative. So mean is not 25. Over here, what's H null? What are you testing?
Systolic blood pressure equal to
Mean
100.
systolic blood pressure is 130. Alternative?
Systolic blood pressure not equal to
Not equal to
130.
130. What's the p-value? Is it more than 0.05?
Yes.
Therefore,
Yes.
therefore,
Yeah. Yes.
no, H null, H alternative. Then what do you do?
Therefore, systolic blood pressure.
No, do not reject H null. In the H null, it means 130. H alternative, the mean is not 130. P-value more than 0.05. Do not reject H null. That means perhaps the mean is 130. Now look at the interval. Confidence interval. Add this and add this. Is it very correct? Is it very correct?
Yes.
Yes. Now 130. Where does it fall? Does it fall inside?
Yes, it falls inside.
130, does it fall inside?
Yes.
All right.
Yes.
What does it
inside.
mean? Yes, it's possible. That means 130. So conclusion, that's objective. This is analysis. These are results. So conclusion, the mean between the population is still around 130. We are confident 95% between 1 to 4 and 113, where 130 falls inside. So conclusion, the mean still around 130. Questions? We done 2 examples. First one, the mean 25, less than 25, p-value less than 0.05. No, it's not. Then where is it? Add these two. We are confident 95% is between this. See, 25 does not fall inside. 25 falls outside. This example, asking whether the mean is 130. So that's a p-value. More than 0.05. Perhaps yes, to the 130 and see it falls inside the interval. That means possible. The mean is still 130. All right. So that's one sample t-test. Now exercise. Test if mean triglyceride. Test if the mean TG. Test if the mean TG equals to 2. Do the test. Test if the mean TG equals to 2. Okay, look at the first table. What's the mean value? Somebody, what's the mean value?
2.78.
Okay, what is standard deviation?
1.75.
All right, you do this, right? What's the p-value?
Less than 0.001.
0.01. It is less than 0.05. Therefore,
Yes. Therefore,
We can
therefore,
reject.
it's less than 0.05. Therefore,
It's not.
The mean is not 2.
mean TG is not 35. I say mean TG is not 2. Mean TG is not 2. Then where is it? At the lower and upper? What's lower and what's upper? Add from here 2, add this, 2, add this. What's the value?
Mm.
2.44.
Yes, 2.4461.
What is this value? Lower value?
Yeah, the lower.
How much?
2.44.
2.44 to
3.12.
3.12.
does a 2 fall inside the interval?
No.
No. That means the mean TG is not 2. Is the conclusion right? Is the conclusion correct? Conclusion is correct. Look at this. What's the assumption? This t-test, what's the assumption? What's the assumption?
The mean of TG is not 2.
So read this. What's the assumption? This assumption, what does it say? Can somebody read? Can somebody read this?
Cases,
Yeah?
cases are independent of
Okay.
each other and data are at least fairly normal.
Normal. The triglycerides are normal. Last week, now test whether triglycerides are normal. Test whether triglyceride is normal.
No.
The test. Do the test.
Not normal.
Not normal. Therefore, the result is not valid. That's why before doing the test, you must analyze this first. At least fairly normal, at least symmetrical, before you can go into this analysis. Right? So yeah, last we found this BMI and SBP are quite normal. We went ahead. But triglyceride is not normal. Therefore, cannot test mean. We cannot test mean. What's the alternative? Cannot use mean. What's the alternative?
We use median.
Median. Right. But here we're not going to do median test. Again, that's very important. Later in assignment, I'll ask you what test going to use, what test going to use, and what's the assignment, the assumption in the test. Right? So must remember every test, there are some assumptions. So one simple t-test, this must be fairly normal. BMI was normal, SBP was normal, we went ahead. When you try triglyceride, it's not normal. So cannot apply mean, cannot test mean. You must test medians. Are we clear?
Yes.
Okay, do one more test. Test if mean SBP, DBP. Test if the mean DBP equals to 90. Test if the mean DBP, DN, equals to 90, 90. What's the mean value? The mean value?
90.56.
90. Right. What is standard deviation?
10.23.
Right. What's the test value?
90.
90. What's the p-value?
0.57.
0.57. Is it more than 0.05?
Yes.
Yes.
Perhaps the mean is still 90. What's the lower limit? What's the upper limit? Now add together 90 plus this, 90 plus this. So what's the interval?
88.6
8.6 to,
to 92.5.
that's 90 fall inside.
Yes.
Yeah. So what's the conclusion? The mean SB in the population is still around 9K. We are 95% confident is between the two limits. That's why I make conclusion. Right. Any questions?
Dear teacher,
Hmm.
which data do you use? You gave us three data chart, but I don't know which data do you
Data
calculate.
set one. Data set one.
Okay, I know. Thank you, teacher.
Okay. Any questions?
Yes.
Any question? Yeah.
Yes.
Yeah.
How to determine the number of 130, 130 or 90 or 25?
130.
Yes. Yes. How to determine the number?
That's a good question. Okay. We take normal BP. Normal BP must be 130 SBP. That's why testing 130. Normal DBP around 90. So these two values are values which are considered normal. The BMI, your BMI again, more than 25 is considered overweight. So these cut points must come from some valid source. That's a WHO. That's a WHO declares BMI more than 25 is overweight. That's why I'm testing 25. WHO says the mean SBP must be 130, so I'm testing 130. Mean DBP must be 90, I'm testing 90. Right? So these values must be from previous literature or based on some guidelines. Do I answer your question?
Excuse me, I have a question.
Yeah.
Since we already know the mean is 167, but why we need to do the t-test?
Say again?
Since we already have the statistics, we know the mean is 108 and 67, but
Yeah.
why we need to do the t-test?
That's my objective. That's my objective.
Mhm.
My objective is now from here to here,
Mhm.
how much difference?
Like 1.33.
Is there a big difference or small difference?
Should be small.
We don't know. We don't know.
Mhm.
Let's have a look at the p-value. Right?
Uh-huh.
If there are small difference that can be significant, we don't know yet. Small
Uh-huh.
difference can be significant. Right? This one, I don't know yet. When I go to collect sample, do I know this?
Maybe not.
No, when I go to collect data, do I know this? No, isn't it? And I go and collect data. Do I know this? Before collect data, do I know this?
I'm not sure since we already get the data, so we can get the mean, right?
No. This is, you're talking before you go and collect data.
Uh-huh.
Do we know this?
We don't know that.
Only after collect data, do analysis, we know this, right?
Uh-huh.
Now the question is it far from 130? So that's the mean value, mean difference.
Mhm.
Is there a big difference or small difference? We don't know.
Mhm.
That's where the p-value comes in.
Mhm.
Right? Just now I showed you.
Okay, I got it.
Correct?
Got it.
All right.
Thank you.
So this is a testing. Tested value, sample value. Are they close? If t is small, how do you know p will be more than 0.05? Then it say no difference. But here look at this test value and sample mean. Then your t is going to be big. So I just focus on the p-value. This p-value more than 0.05, we say no difference. They're quite close. This p-value less than 0.0 means they're very far apart. You're asking whether is it possible to mean a certain value? Perhaps yes. What about here? No. So that's example, two examples here. Right? P-value less than 0.05. It's not 25. This we don't know. We don't know before when to collect data. This one, we want to know this value or not. Why? More than 25 is obvious. This we decide. This from the sample, right? Same thing here. 130, how do you know? Let's say WHO. You say 130 is normal. We don't know this before you collect data. So test it out. P-value more than 0.05. Yes, perhaps still 130.
And could you please explain what is WHO?
World Health Organization. World Health Organization is the one that gives the guidelines. Different country also may be different.
So we can find a number, the assumed number from the WHO, right?
WHO, yeah. The WHO.
Oh.
Just type there.
Oh,
Type there. WHO guideline, blood pressure.
okay,
WHO
thank you very
guideline,
much.
BMI. Right? A lot of
Okay.
guidelines. Yes. Right. Any other questions? Okay. Let's stop this.